Thank you so much, sir, and thank you for giving me this opportunity. Let me share my screen. Is it visible? Very good evening, everyone. I am Dr. Poornima Tiwari, Associate Professor of Mathematics, Faculty of Science, the Bhopal School of Social Sciences. I have more than 17 years of experience in teaching in Higher Educational Institute of Madhya Pradesh. I published more than 10 research papers and presented in national and international conferences of repute. I was invited for as a resource person in several occasions or as an expert. I'm external examiner of various organizations. And in today's session, we will discuss the topic reviving the legacy of ancient Indian mathematics for holistic education as envisioned by NEP 2020. Now the point is why we are discussing such topic. Because we have a very great history, but we are not aware with several contribution of ancient scientists. So National Education Policy 2020 provide a provision for this. And in today's session, we will unlock ancient wisdom, visualizing the mathematical genius encoded in classical text. To understand envisions and aims of NEP 2020 and to know the long-term vision for India's education system. The National Education Policy is a vision for holistic multidisciplinary education, and it is a transformative approach for integrating India's rich intellectual heritage along with the modern pedagogy. Many of you may aware about this term IKS, Indian Knowledge System, which includes not only mathematics but astronomy, philosophy, culture, psychology, and ancient science, and many more. To integrate this with the curriculum, we need certain reform as well as we need a proper blending of traditional wisdom with contemporary scientific thinking. And that will provide to foster critical thinking, problem solving ability, cultural rootedness in students, and nurturing well rounded individuals. Now, what are the benefits of bridging past and present, especially in context of mathematics? That provides some unique benefits, enhancing analytical and critical skills for future challenges. I would like to inform you that Madhya Pradesh is the second state who implemented national education policy in the year 21-22. And initially, they have introduced a generic elective course in mathematics, which is entitled as History of Indian Mathematics and Vedic Mathematics. I myself perform a short kind of research study to assess the impact of such introduction of this course, especially in reference to higher educational institute. And I found very positive result. So that's why this system is beneficial for our students when we have a proper blend of traditional and modern technology. We may use the logical framework that is used in Indian philosophy, mainly Nyaya and Vaishvik, that enrich analytical thinking. Ancient technique or ancient method enhance mental calculation and problem solving skills, as well as they give comparatively accurate results. And we can prepare our students to face interdisciplinary challenges, especially in science and technology. UGC and other educational bodies are working on that. They propose a new elective courses in ancient mathematics At undergraduate level, they introduce some topic, especially geometry, algebra, trigonometry. And as I inform you that with the implementation of NEP 2020, they have introduced a course. But in the present time, from the academic session 25-26, every first unit of every subject, every course is related to Indian knowledge system. So that's the update, that how we are integrating our ancient techniques along with the modern education. So the educational landscape in India is undergoing a transformative shift with the implementation of NEP 2020, as it emphasizes holistic, flexible and culturally rooted learning. It advocates for a learner-centered approach and also encourages educational institute to embrace traditional learning system alongside modern pedagogy. So in this evolving context, there is renewed interest in integrating IKS, Indigenous Knowledge System, into the mainstream curriculum, and the role of ancient Indian mathematics in modern education has now become a significant area of research, particularly in the wake of National Education Policy 2020, and it seeks to integrate India's rich intellectual tradition with the contemporary learning needs. Now, why this mathematics or ancient mathematics? As we know, it is a gate and key to the sciences. The history of Indian mathematics is rich, and it spans from Vedic period through the classical age. Starting from Vedas that enclose notion of mathematics, and they are the first written evidence of ancient Indian mathematical system. As we all aware that we have four Vedas, the oldest one Rig Veda, then Yajurveda, Samved, Atharved. They are very comprehensive Indian texts which were revealed and recited thousands of years ago. Even we don't know the exact duration of their construction, but it is around 500 CE. They were primarily used in Hindu rituals, but their core values are often not fully understood. In Vedic era, mathematical concepts are applied for calculating the times for Vedic rituals and construction of altars. That altars means Vedi, जहाँ पे यज्ञ वगैरह होते थे. So that use precise geometrical concepts. And the Vedas have 6 Vedangnas named as Kalpa, Shiksha, Vyakaran, Chanda, Niruktam, Jyotisha. And out of these 3, Kalpa, Jyotisha, Chanda, and mainly Kalpa and Jyotisha includes mathematics widely. The Vedangna Kalpa focuses on preparation of altars that use geometrical ideology, which are called Sulbha Sutra. So, the written evidence starts for the Indian mathematical system. The foundation is Sulbha Sutra, which is constructed around 800 to 500 BC, the late Vedic era, or we can say pre-classical era. Those texts were mostly written by Bodhayan, Apasthama, and Katyayan. These texts, Sulbha Sutras, provide precise geometric rules for constructing of fire altars that are used in the Hindu rituals. Sulbha means code, or Sutra means rule. So they have the precise rule. Now, I would like to seek your attention on Bodhayan Sulbha Sutra, which is Dirgha Chatushchadaya Rajju Parshvamani Tiyegmani Chayapat Bhute Kurut Istudubham Karoti. This sutra is written in the Sulbha Sutra given by Bodhayan, and later on it is found that This statement is equivalent to modern time Pythagoras theorem. Sulbha Sutras also includes transformation from one geometric shape to another. For example, squaring to circle. Here I have mentioned this picture, how they have constructed square and circle, or transform circle to square and square to circles. The another picture includes the diagram for construction of altars, that constructed in two layers, first and second layers. Sulbha Sutra also include accurate approximation for the irrational number, mainly 2. In the post-Vedic era, we have Pingla Chanda Shastra, which includes mainly binary numeral system and Fibonacci numbers, which are still in the use, and some Jain mathematical text that deals with permutation and combination, and also some content related to infinity. The golden age of Indian mathematics started in 499 CE with Aryabhatta. He wrote the text Aryabhattaya. We all are aware that invention of zero, place value system, decimal value system, those were invented at that time and they are still in use as it is. He also developed several trigonometric concepts, sine and sine value table. Most importantly, he calculated a highly accurate value of pi, and he stated that it is an approximate value which is correct up to 4 decimal places, that is 3.1416, and that's true in the present case also. He also presented a general solution for indeterminate linear equation, Kutka method. So he has lots of contribution in mathematics, and not only in mathematics, in the field of astronomy too. He calculates the reason or time of solar and lunar eclipses too. The legacy of Aryabhatta is carried forward by Brahmagupta. He was also a mathematician come astronomer. He written the text Brahma Isputa Siddhanta around 628 CE. He can be, we can call him as a master of zero and negative number, because he was the first one who provided clear and systematic rules for arithmetic operation involving zero and negative number. So you can see this sutra which is given by Brahmagupta is dhanyo dhanam rinyo rinam dhanam rinyo antar sam ekam kha rinam ekam cha dhanam rinam dhanam shunyo shunyo sunyam. Dhana means positive number, rin means negative, sunya means zero. So he provided the precise rule that if we add a positive number with a positive number, we get another positive number. If we add a negative number with negative, we get another negative number. A positive or negative gives positive or negative as per the precise rule that we are using. And when we add 0 to a positive number, we get a positive number. And when we add 0 with a negative number, we get another negative number. And he also mentioned that addition of 0 with 0 gives 0. So those precise rules were given by Brahmagupta and they are still in the use. He also presented a general solution for quadratic equation. He derived formula to calculate area of cyclic quadrilateral and Brahmagupta's theorem that concern diagonals of a cyclic quadrilaters. So he also contributed a lot in the field of mathematics. The same legacy is carried by Bhaskaracharya. He wrote the text Siddhanta Shiromani around 1150 CE. That Siddhanta Shiromani has 4 different parts. The first part is Leelavati, that deals with arithmetic calculation. Second part is Bij Ganita that deals with algebra. Third part is Greh Ganita that deals with the study of planets. And the fourth part is Goladhyay that study spheres. So several contribution in the field of algebra, arithmetics as well as astronomy was credited to Bhaskaracharya. He developed a cyclic method for solving indeterminate quadratic equation, and in modern time it is equal to Pale's equation. He also introduced some concept of differential calculus. For example, the derivative being zero at the extreme of the function. And he used this concept in context of astronomical rates of change. He discussed the concept of a number divided by zero is resulting infinity. At that time, it is referred as Khakara. And we are still using the same concept given by Bhaskaracharya. The most important discoveries the later on is developed by various scholars of the Kerala School of Mathematics and Astronomy. This is founded by Madhava of Sangramarma, and he made crucial contribution in the field of calculus, infinite series, trigonometry, much before the similar discoveries in European countries. Now, I would like to quote one example that Madhava developed a series which is given here. Pi by 4 is equal to summation n varies from 0 to infinity minus 1 to the power n 2n plus 1. And you can see the time period, it is near about 14th century. But this series is credited to Leibniz, who is the mathematician near about 16th, 17th century. So he got credit very late for that series, and later on this series is referred as Madhava Leibniz series. He also worked on various series. Another series is given here. Pi is equal to square root of 12. Summation varies from 0 to infinity minus 1 to the power I, 2i plus 1, 3 to the power I. And another approximation of this. He not only worked on these 2-3 series, he worked on several infinite series and expansion of trigonometric functions, whether the sine, cos, tan, and also find approximated value of pi. Several other scholars are also contributed in the field of mathematics and astronomy from the Kerala School of Mathematics and Astronomy. The next is Parameshwara Nambudari, near about 1380 to 1460. He was also an astronomer and mathematician who developed the Ganita system for astronomical calculation, and he authored numerous works. And the next is Nilkanta Somyaji during the period 1444 to 1544 CE. He was an astronomer and also contributed to mathematical advancement of the school. Another renowned scholar of the Kerala School of Mathematics and Astronomy is Deva. In the duration 1500 to 1575 CE, he wrote a text, Yukti Bhasha, mainly in the Malayalam. It is a text written in Malayali. And the text is a landmark in the history of Indian mathematics because it is the first written document that provides detailed proof. At that time, it refers as Upatti. He provides proof for the derivation of various infinite series, especially the series that developed by Madhava. So earlier, to Deva, mathematicians were working on the concept, but they don't provide proof or reason for those concepts. So Jasdeva have started that train to provide the proof of any concept. This in that way, this text Yukti Bhasha is very unique, and it is known for early element of calculus like given by the Taylor and other, or in infinite series. Other scholars of the Kerala School of Mathematics and Astronomy are Shankaravarya and Chitrabhanu. Chitrabhanu is 16th century mathematician and a student of Nilkanta Somyaji. He wrote an algebraic pesticides and astronomical manual. So when we talk about ancient Indian mathematics, it influenced the world, because it's not only about computational, it is a systematic, algebraic, and analytical approach. It deeply influenced global mathematics, and scholars like Aryabhatta, Brahmagupta, Bhaskaracharya, Madhva, Varamihir, and many more developed the concepts ahead of their time, whether it is the concept of zero, decimal place value system, algebraic operations, negative numbers, use and concept of infinity, infinite series, several geometrical concepts, in the form of trigonometry as well as calculus. So we have those concepts years ago, the discoveries by European, but we don't get any credit for that. And the main reason was, the main constraint for it was the language, as those texts are written in Sanskrit. But even though some idea traveled to other parts of world through Arab scholars and trade routes, and then the another numeral system, Hindu Arabic numeral system, is come into the picture, and that system is still used internationally. So Indian method of calculation, whether related to geometry or astronomy, shaped later development in Islamic and European mathematics, as when the scholars got aware about that, and they form a crucial foundation for modern science and technology. Now, after all these introducing integrating knowledge system or ancient mathematical technique or ancient science or technology, the main question is the transformative impact of reviving ancient mathematics. Is there any positive impact or not? And as I told you, I myself did a study, a short research study on impact of introducing such techniques at higher educational level, and I found very positive results. And those techniques are very rich, they are very robust and culturally aware, that involves an innovative educational ecosystem that increase critical and logical thinking, a mental calculation, and most important, accuracy in the result. For several methods, we don't need a pen or paper, we can just do the calculation on tips. So by introducing such concept, especially in the higher educational institute, it is a cultural pride that cultivates pride in Indians' intellectual heritage and contributions. Holistic learning. It encourages holistic education that increases cultural, science, and critical inquiry. That align with the NEP goal to produce globally competent, culturally rooted, and innovative graduates. And it is useful for sustainable future, for sustainable development by applying knowledge to modern problem, ensuring a relevant and impactful education. So I find that integration of Indian knowledge system in the curriculum, not as a whole, but some part of the main curriculum, is very beneficial for the students. So the conclusion of this study is embracing the Indian mathematical legacy for the future generation is needed. The National Education Policy 2020 and several UGC initiatives representing a role in reconnecting our education system with India's profound mathematical past. This revival promises a more inclusive, interdisciplinary, and inspiring learning journey for the all. Those who forget the past relinquish the future. That's my point of view on the topic. And as I told you, we have implemented this national education policy in the year 21-22 itself, and it is still in the progress. We are still changing some concept. Curriculum is still revising. Earlier a course, then one unit in each course based on IKS. So the research is ongoing on the topic reviving ancient Indian mathematics. So as we get some more result, we'll discuss in future. If anyone have any query regarding the topic or would like to say anything, you are most welcome. Sir, I would like to ask one thing that someone commented PPT is not visible, but the screen was shared and it was visible as I asked you earlier. Was it not? No, if anyone needs a PPT, I may share it because it just. Okay, sir. So thank you so much, sir, for giving me this opportunity. It is also a learning for me because I am dealing with the pure mathematics, and because of the interest of institution, I have shifted my interest to Indian knowledge system. So that's the need for present time. थैंक यू सर.
सर एक क्वेश्चन था मेरा.
जी सर पूछिए.
मैडम अभी जो वैदिक जो आप मैथमेटिक्स बोल रहे थे तो फ्यूचर में क्या इसका बेनिफिट क्या है फ्यूचर में?
देखिए सर हाँ जी सर आई एम कमिंग टू दैट पॉइंट. आई एम अंडरस्टैंडिंग यू आर मतलब आप जो कहना चाह रहे हैं ना उससे हमने भी डील किया था जब NEP का जब हमने कोर्स देखा और उसमें इतने सारे एंशिएंट मैथमेटिशियन की बायोग्राफीज है, इतनी सारी टेक्निक्स हैं. मैं आपको अपना एक्सपीरियंस शेयर करती हूँ. जब हमने ये पढ़ाना शुरू किया तो हमें भी कुछ ही चीजें पता थी कि डिस्कवरीज क्या हुई, लाइक जीरो प्लेस वैल्यू सिस्टम, हमें भी इतना ही पता था. वी डोंट नो दैट नेगेटिव नंबर सिस्टम वाज आल्सो इन्वेंटेड इन द इंडिया. approximated value of pi, trigonometric series, infinite series जो हम डे टू डे लाइफ में यूज कर रहे हैं, हम उसका क्रेडिट लेबनीज, न्यूटन और टेलर्स इनको दे रहे थे. Those were written in 16th और 17th century. हमें पता लगा वो तो हमारे यहाँ 13-14 सेंचुरी में काम हो चुका था. So we were not aware with our own history. सबसे पहला पॉइंट. सेकेंड पॉइंट, ये जो मेथड है, यदि आप मैथमेटिक्स से डील करते हैं तो आपको पता होगा डिफरेंशिएशन इंटीग्रेशन बच्चों को बहुत डिफिकल्ट लगता है। आप मैथमेटिक्स से हैं?
नहीं मैडम।
अच्छा, तो ये टॉपिक है, आप किसी भी मैथमेटिक्स टीचर से पूछिएगा। सो डिफरेंशिएशन इंटीग्रेशन में बच्चे बहुत उलझते हैं, बट एंशिएंट मैथमेटिक्स टेक्निक से वो बिल्कुल टिप्स पे बहुत इजीली और एक्यूरेटली सॉल्व हो जाता है। सो दोज आर द बेनिफिट to have pride on our own culture, number one, and to know the short tricks, short methods, which are very well designed as well as accurate. That's my finding. Any other
मैडम
query?
मेरा और एक क्वेश्चन है मैडम।
हाँ जी सर, कहिए।
अभी जो वैदिक मैथमेटिक्स जो है,
हाँ जी सर।
वो रिसर्च में
हाँ,
उसका यूजेस नहीं है मैडम।
नहीं, वैदिक मैथमेटिक्स का एक्चुअली क्या है, देखिए वैदिक मैथमेटिक्स एक बहुत नैरो डोमेन है जो मैं आपको बताना चाहूंगी। इट इज बेस्ड ऑन ओनली 16 सूत्रास एंड 13 सब सूत्रास विच प्रोवाइड अ क्विक मेथड, है ना, इससे ज्यादा नहीं है। बट द एंशियंट जो टेक्निक है, यदि हम सारी मेथड्स को एनालाइज करें तो आप जरा सोचिए कि जो 16-17 सेंचुरी या इतने मॉडर्न टाइम में भी जो हम पाई की वैल्यू निकाल रहे हैं, वो 5th-6th सेंचुरी में आर्यभट्टा ने कैसे निकाली, व्हाट वर द टेक्निक्स, है ना, जो वो इतना एक्यूरेट कैलकुलेशन कर पाए, क्या एल्गोरिथमिक अप्रोच उन्होंने ऑप्ट करी। तो हमें वो मतलब कॉन्सेप्ट के जो बिहाइंड द कर्टन है, वी शुड नो दैट, सो दैट वी कैन डू सम मोर डिस्कवरीज।
बराबर है।
Any other query by anyone I would like to address?
थैंक यू
That will
मैडम।
enrich my knowledge too.
थैंक यू मैडम।
Thank you, sir. Thank you, sir. May I leave? Okay, okay. Thank you, sir. Thank you, everyone, for the patient listening.